Good evening, Kartika. Yeah, good evening, Kartika. Just wait till everyone joins.
Good evening, sir.
Yeah. Wait 2 minutes till everyone joins.
Good evening, sir.
Hey, Rai hai wo. Yeah, good evening, Abhinav. Good evening,
sir.
Abhinav. Good evening.
Good evening.
So, I think almost everyone has joined now. Let me see. Yeah, we can continue now. Uh, Today we have to do question answers of the chapter carbon and its compounds. We'll do one assignment on. Start with NCERT questions. ठीक है बेटा. So we were here drawing the electron dot structures for ethanoic acid, H2S, propanol, and F2. So is there anyone who is finding anything difficult in them? In the last class, we had drawn the structure of ethanoic acid and we had to draw the structure of H2S, hydrogen sulfide. You see? Hydrogen sulfide, here we see that sulfur is the central atom and to the sulfur the two hydrogen atoms are attached. Since a hydrogen atom can form only one bond, so if I draw the bond structure, it would be like this. Then, as I told you, to get the electron dot structure, you must use or represent the electrons with your dot. So, hydrogen, sulfur, hydrogen, you write like this. Remove each of the bond and at every bond replace it with 2 electrons. So 2 electrons I replace. Now I complete the valence electrons of each element. So the valence electron of hydrogen is complete. The valence electrons of this hydrogen is also complete. The valence electron of sulfur is incomplete. As this sulfur has 6 electrons. So we will representing here 2 more electrons. Two here, two here. So now sulfur has completed its octet. We can see here that the sulfur has completed 6 electrons. Its valence electron is complete, valence for hydrogen is complete, and valence for the other hydrogen is also complete. Now, to show the octet configuration, we'll be drawing circles. Okay. So we'll draw circles around every element. So circle will be around sulfur such that it completes its octet. So it includes all the shared pair of electrons. So in this way you can see that sulfur has all the 8 electrons. Got it? If I see for hydrogen, so for hydrogen I do like this. Since hydrogen has shared 1 electron, so it will be gaining benefit of 1 electron. Also, hydrogen can accommodate maximum of 2 electrons in its outermost shell. So the capacity of the outermost shell is 2 only. So that is how hydrogen can adjust just 2 electrons. So the K shell of hydrogen is fully filled. Now for the other hydrogen, again we'll draw a circle representing the hydrogen and its 2 electrons. So this is how the shell for hydrogen is complete. So this is the electron dot structure for H2S. Okay. Now all of you try to draw the electron dot structure of propanol. First make its bond structure, then replace the bonds with electrons. Okay.
Good evening, sir.
Yeah, good evening, Sumuk. Welcome to class. So Sumuk, draw the structure for propanol.
Yes, sir.
So if you have completed the bond structure, you can check it from here. The bond structure of the propanol would be 3 carbon atoms, each linked with a single bond. Since it is propane, so there will be single bond between each carbon atom. It's prop, so there will be 3 carbon atoms. All right. Now its own O and E, since it is a ketone, and for the ketone we know that the functional group is C double bond O and C. On both the sides there can be only carbon atoms. So this double bond O should be on the second carbon. It cannot be on the first, it cannot be on the third. It can only be on the second carbon atom. So you make it like this. Now this is complete. So you just need to you just need to write down or fulfill everywhere with the hydrogen atom. Alright. So all the vacant spaces, that means vacant structures, will be replaced with hydrogen atom. So this carbon, the first carbon, it has 3 vacant bonds which will be bonded with hydrogen. So this you get hydrogen at all the 3 places. The valency for the central one, it is satisfied. It has already 4 bonds, so no hydrogen at the second carbon. For the last carbon, you can see again there will be 3 hydrogen atoms. Now to obtain the electron dot structure for this, you will first replace all the bonds with electrons. So every bond will be replaced with 2 electrons. And then after that, according to check the valence electron for each element. If they are all there, it's good. If they are not there, complete their valence electron. Okay, see. So I write all the elements here: carbon, carbon, carbon. Here hydrogen, hydrogen, and hydrogen. Here oxygen. Here also hydrogen, hydrogen, and hydrogen. Now replacing each bond with two electrons. So this bond replaced with two electrons. 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 Here is also bond, so replaced with two electrons. Here there is a double bond, so there will be four electrons, two from each. Here, one, 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 one. Okay. So have we replaced every bond with two electrons? Yeah, have we replaced every bond with two electrons?
Yes, sir.
Now, just check, is the valence electron complete for all of them? Hydrogen has one valence electron, so it's shown. So everywhere hydrogen is being shown with one valence electron. Check for carbon. So here, carbon has four valence electrons, which is represented. Second carbon also has four electrons, which are represented. This carbon also has four valence electrons, which are represented. What about the oxygen? Are all the valence electrons represented?
No.
No. So how many electrons are remaining? Oxygen has a valence electron of 6, out of which 2 have been represented. So how many are still remaining?
4 electrons should be
Four
drawn.
electrons. Yeah. So I draw here 2 electrons and one here, one on this side. So this complete the valence electron for oxygen. Now I draw the circles around each of the element such that its octet or its valency should be satisfied. So for hydrogen, I draw this. Okay, let's start with carbon. So for this carbon, I should include all the electrons which are shared with this carbon. So I get it like this. Now, for every hydrogen here, two electrons, here also two, okay, here also two. Oh, not the last one. Last one is carbon. So this is complete. This is okay now. Now again, for this carbon, there should be 8 electrons. So see how 8 electrons are completed. 4 of this carbon, 2 from the upper oxygen, 1 from this carbon, 1 from this carbon. So you draw a circle like this, including all the shared electrons. So you can count now that the number of electrons which this carbon is holding is 8. Is it 8? Let's check out. Yes, it's 8. Now for this oxygen. So if I draw for this oxygen, see this oxygen has itself 6 and 2 electrons it has shared with oxygen. 2 electrons it has shared with carbon, so it gets these 2 electrons more and hence completes its octet like this. Then for this carbon atom, if you look for this carbon atom, so complete the octet of this carbon atom with the electrons which it has shared. So 2 from hydrogen, from carbon, from each hydrogen completing its octet. So for this carbon also, all the octet is complete. Then remaining for hydrogen, that is for this one. For this one, hydrogen should have only 2 electrons. Okay. There is one more electron which we haven't drawn. This is here. All right. So see, is this okay now? How many of you have drawn it the same?
I can see, sir.
Okay. Anyone got a different answer or was confused with this? Anyone who didn't understood why we are drawing the circles, how long we have to draw the circles? Anyone? Aryan?
Sir, and yeah,
Yes, sir.
why are the circles important?
Circles are important to represent the octet configuration, to represent and show that which electrons are belonging to which element.
Okay, sir.
So now the next one, F2. And now this one I will be checking. I will be checking for everyone the structure of F2. First, draw the bond structure and then draw the electron dot structure for F2. First, draw the bond structure. You see. So for this one, okay, anyone who has done this?
Sir, one
F,
minute.
it's not a big one, it's a small one. So everyone should be able to complete it in a minute only. Not more than a minute. You have to draw the diagram for F2.
Sir, can you see me?
Just one minute. Yeah, F2. All right. So just one minute, hold it. 2468, 2468. Yeah, it's correct. It's the bond
Thank
structure
you.
is incorrect. Bond structure is incorrect. Sumuk, just check the bond structure. Check the bond structure of F2.
Hack. Sir, 8, 8.
In the bond structure, you have drawn two bonds between fluorine and chlorine.
Yes, sir.
Okay, so there has to be just one bond. Yeah. Yeah, now it's okay. Now it's okay. Okay, now I think we can move to the next question. Okay, next question is what is an homologous series? Explain with an example. So what is a homologous series? Yeah, what is homologous series? Kartika, what is a homologous series? Dhairya? Dhairya, are you there?
Yes, sir.
Okay, Dhairya. So what is a homologous series?
Sir, homologous series is when between two like compounds there is the difference of uh, carbon and hydrogen is CH2, like it's equal.
Okay, so just you need a proper definition. So homologous series It is a family of hydrocarbons. It is a family of hydrocarbons that where every successive member every successive member differs by a CH2 group. So if here you see that every successive member differ by a CH2 group that we call as a homologous series. So as an example, anyone give any example for this? I hope the screen is visible. Is the screen visible to everyone? Is the screen visible?
Yes, sir.
Yes, sir.
Yes. All right. So see, give me the example of the homologous series.
So alkane series is an example.
Which one?
So alkanes like CH4C2H6.
Okay, so any two, three members you need to write down from the group. So you write CH4, you write C2H6, you write C3H8. Okay, so they are you write C4H10. All these are the homologous series. This is a homologous series. Okay, the next next question is here. How can ethanol and ethanoic acid be differentiated on the basis of physical and chemical properties? So how can you differentiate between ethanol and ethanoic acid on the basis of their physical properties? Yes,
Sir,
can
smell
anyone?
and taste. Smell and
Yeah,
taste.
yes, obviously the smell. You can differentiate them with the help of the smell. You can differentiate them with the help of their boiling points and the freezing point. The freezing point of ethanoic acid is very less. It is about 12 to 15 degrees centigrade. That is why it is also called as glacial acetic acid. Glacial acid. Okay, as it freezes. Then why does micelle formation take place when soap is added to water? Harry, why does the micelle formation take place when soap is added to water?
Sir, can you repeat?
Why does micelle formation take place when soap is added to water? That
Sir,
means in this one, you have to explain the micelle formation, how the micelle formation occurs.
sir, don't know, sir.
No. Okay, how the micelles are formed and what are micelles?
Sir, they're like tiny particles, right? Like I don't know, sir.
Okay. Anyone else who can tell me what are micelles?
Sir, they are they are formed due to the hydrocarbon chains, which are like soluble, which have two parts, which are soluble and insoluble with water. So it leads to the structure called say.
It is called. See, first of all, we need to explain here the structure of a micelle. Okay. we need to explain the structure of a soap. Then we can explain the structure of micelle. Okay, is there anyone who knows and I haven't asked that person? Is there anyone who knows this? What are micelles? Otherwise, just after explaining this, I'll ask you. I'll ask you what are micelles.
No, sir.
No. All right.
No, sir.
Okay, so I think no one knows about the micelles. I tell you now what are micelles and how it works. Okay. So micelles, first we describe a soap molecule. Okay. So we describe here a soap molecule and then we'll see the formation of a micelles. We say that a soap soap molecule is a long chain of fatty acids having a hydrophilic end and a hydrophobic end. And hydrophobic end. So it has two ends, hydrophilic and hydrophobic end. The hydrophobic end, the hydrophobic ends of micelles attach themselves to the dirt particles. The dirt particles as the dirt particles are oily in nature. As the dirt particle is oily, so they find it better to attach with the dirt particles. Okay. Then we say that the hydrophilic end the hydrophilic end attaches itself. Okay, so the hydrophilic end attaches itself with water molecule. Right? So the hydrophilic end attaches itself with the water molecule. Okay. So this leads to the formation of structures called micelles. Or you can say the structures. Okay, this leads to the formation of structures called micelles, where a number of dirt particles or a number of soap molecules are attached with a number of soap molecules are attached with dirt. And now here you will draw the structure of the, you will also draw here the structure of that micelle. So now I think everyone can tell what a micelle is. Just go through this, what a micelle is and how it is formed. And after this, you should be able to identify, you should be able to write what are micelles. Yeah. Okay, so is this done with everyone? All right, we move
Yes,
to
sir.
the next one. Will a micelle be formed in other solvents such as ethanol also? So will there be a micelle formed in ethanol also? Yes, how many of you think that there will be a micelle formed in ethanol also?
It will not form, right, sir?
Yeah, it will not form, as ethanol itself has both hydrophobic and hydrophilic ends. It can dissolve in water, so it has an end which is hydrophilic and it has an end which is hydrophobic. Both ends are present with it. Okay, so that is why there will not be any formation of micelle in ethanol. Like it has a carbon molecule also and it has an oxygen molecule also. Okay, so there will be no micelle formation with it. Explain why carbon and its compounds used as fuels for most applications. So why we use carbon and its compounds for most of the applications as fuels? Okay, no one is answering. Abhinav? Abhinav?
Yes, sir.
Okay, can you answer this next one? Why this one? Why carbonates compounds are used as fuels for most applications as fuels? Why they are used as fuels?
Is it because they're organic compounds and they burn well?
What happens? See, carbon and its compounds they combine or they oxidize with on reacting with oxygen or in combustion with oxygen, they form carbon dioxide and water. They form carbon dioxide and water. That is why they are used as fuels. Explain the formation of scum when hard water is treated with soap. So when hard water is treated with soap, how is the scum formed? No ideas. Your people are not taking any interest. No answers. Yes. What is a scum? What a scum is? What is a scum?
Sir, it's like the reaction of hard water with soap.
Mhm. So when hard water reacts with soap, then what is a scum? It is a solid precipitate which is formed. A solid precipitate which is formed, right? A solid precipitate is formed when hard water reacts with soap. That we call as a scum. Got it? So this is scum. Then next question. What change will you observe if you test soap with the litmus paper?
Blue.
So is the soap acidic or basic in nature?
Base.
Soap is basic in nature. Okay, so it will give you positive test with the basic indicator, which is it will turn the red litmus to blue. Okay, then what is hydrogenation and what is its industrial application? So what is hydrogenation? Yes, anyone? Can anyone explain what is hydrogenation? The addition of hydrogen to the unsaturated hydrocarbons. The addition of hydrogen to the unsaturated hydrocarbons is called
To make
hydrogenation.
it saturated.
Yeah, make it saturated. Okay. You just what is its industrial application? It is used in the hydrogenation of vegetable oils and to produce dalda.
Yes.
Okay. Next one. Which of the following hydrocarbons undergo addition reactions? So you have been given some of the hydrocarbons and you have to say that which one of them undergoes hydrogenation reaction. So undergo addition reaction. Which will go undergo addition reaction? Okay, tell me which compounds undergo addition reactions. Yes, anyone? Oh my God. Oh my God.
Are the like saturated ones?
What? The saturated ones, they will undergo elimination reaction. The unsaturated ones will go addition reactions. Okay. So from these ones, you have to find the ones which are, from these ones, you have to find the ones which are unsaturated. Okay, the unsaturated will undergo hydrogenation reaction.
The
And
second
to
one,
identify that, you should know the formula for the unsaturated ones, which is CnH2n or CnH2n minus 2. So the first one is C2H6, which is CnH2n plus 2, that is an alkane. C3H8, it is an alkene, so it will undergo addition reaction. C3H6, this is
the
also an
third
alkene.
one,
Yeah, sorry,
C2H2.
C3H8 will not go, it is alkane. C3H6 will undergo, C2H2 will undergo. So these two, C3H8 and C3H6 and C2H2 will undergo addition reaction. All right. Okay, just complete this question 14 and 15. With this, we have completed your chemistry syllabus. We'll see a few assignments from this chapter in the next week. Okay. So your physics and chemistry both are complete. We'll just do quick revisions in the next class. All right. Bye,
Okay, sir.
everyone. Goodbye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.